Welcome back to Adventures in Reach. Today I'm going to be talking about the address system, or ADDRESS, to evaluate anchor systems for when you are climbing or rappelling. So behind me here I have a very simple anchor system. A 3-wrap 2-pull in purple around this tree, and then a basket hitch right here in white. I have an auto-locking carabiner, then a locking carabiner, so screw lock. Then at the apex here, I have each one tied with a overhand on a bight. So the first A refers to angle. And what I mean by that is the angle at the apex of the anchor where the two anchor points come together. So that's also important where you go around a tree or a rock. It has the same effect. So the greater the angle, the more force is applied to each anchor. The more in line they are, the less force there is per anchor. So if you haven't yet, you should watch my video about the anatomical references for angles, which is super helpful in describing this. But essentially, you want to keep your anchor system with a 90-degree or lower, smaller angle, ideally, and never to exceed 120. So here, when we pull this tight, we have probably a 45 or 50-degree angle, which means that each anchor holds about 50% of the load, or half the weight on that one and half the weight on that one. The next letter is D for distance. So if this red line here is the edge, then we want this to come to the correct distance away from our edge. That depends on your setup, whether this apex needs to be at your edge or over your edge, wherever. It just needs to be in a good spot for the belayer or for that anchor to minimize wear on the rope and make it convenient for your belayers. The next letter, or the second D, refers to the direction. We have this anchor system that is pointed in that direction. So if we don't want to climb there or rappel there, it's not going to do us any good. So if we want to go over there, check out what happens to the anchor, right? We go that way, and now half of our anchor system isn't even doing anything. In this system, it's single direction. It has to go in that direction for force, otherwise we're only using half of it. The next letter stands for redundancy. The next letter stands for redundancy. Oh, yeah. So essentially what this means is that we have multiple things to fall back on if something were to fail. So let's check it out. So part of this means that we have an anchor here and we have a second anchor here. We're not relying on either one of those individually. We also have these lines that come down, and there's these knots tied here, and that separates them. So this is a separate system than this. So if one were to break, we have redundancy, and the other one would hold us up. Now, we don't want to get too crazy with redundancy because we can get into a situation where we're making a system overly complicated. It doesn't do us any good to put 2 carabiners here, and if 2 carabiners is better, well, what about 3? At some point, that's just ridiculous. So we want to look at the load ratings of our equipment and think about the weight that's being put on that system, and is it enough? Think about it. We have 1 rope, unless you're doing rescue. We have 1 belay device. We generally have 1 carabiner. So at some point, being redundant just isn't possible and not very realistic. So just make sure that you consider it and consider where it's needed. The next letter is equalization. So I talked about the direction of this anchor system and how it has to go in one direction for both anchors to be used. So equalization really is addressing that sort of thing. This really comes into play with a 3-point anchor system, where not only do we have the 2 like this, but we have a 3rd one in here, and now what's kind of common is that you have 2 that are holding and then 1 that's kind of flopping. So you really want to work on that and make sure that all 3 anchor points are doing the same job and holding the same amount of weight. There are several options to equalize anchors, such as using this magic X method. However, on many of these systems, there is the risk that if it were to fail on one side, that it would have to drop several inches before it were to catch. The next letter is S for shock load. Now, shock load is when something in the system fails and it drops. And when you hit the end of your rope and it catches you and your harness transfers that energy or that momentum into your body, that's the shock load. We really want to avoid that at all costs anyway, because it puts this drastic amount of force onto our system, and we never want to drop more than 18 inches. At 18 inches, produces about 4 kilonewtons worth of force, and above that, we start getting into this zone where it's pretty dangerous. Now, that's going to be a little different if you're climbing and you're falling onto a dynamic rope that is intended for that, because it's got a high elongation or stretch to it, and it's intended to really transfer some of that force into the rope and absorb it that way instead of into your body. So shock load here, when we're talking about anchors, is if one of these unclipped, what would happen? And in this case, it would just swing to the side, okay? But there are anchor systems where if it were to break one side, the whole thing would go. The last letter that we're going to consider is S for safety. So safety is kind of an all-encompassing thing, and it's really one of those things that gets forgotten sometimes. And so it actually has a ton of things under it. And so part of that is considering what are the ratings of our system components, right? What's the rating of this webbing, this sewn loop, this carabiner? We want to think about too, what about our anchors themselves? This tree doesn't look so great. We want to go through and check each component. So here, we want to make sure that anchors are not rubbing anywhere that is going to be dangerous. So here, that's good. It's around the back. It's not all twisted up. There's nothing sharp back here. This is a self-locking carabiner, and so that is safe. This is a correctly tied overhand on a bight. Over here, we have a correctly tied water knot. We have a 3-wrap-2 pull. We have a locked screw gate carabiner. So we make sure that each of these are locked, and we go around and squeeze them. Again, this is tied correctly. We want to look at the tails on knots and make sure that there's about 4 inches or enough that we can squeeze it in our fist and there's something sticking out on the other side of our fist. Again, at the apex, we're going to look at, is this locked and ready to go? Is this line in between, if it's connecting like that, is this tensioned or is it loose? This is nice and loose, so there's no sideways stress or force on this. The other thing we can think about is, are people ready? Safety-wise, like, am I alert? Am I ready? Do I know what I'm doing? Or do I have questions? Do they need leather gloves so that they can control the rope without getting hurt or wanting to let go? Is the belay device hooked up correctly? Do you have a knot at the end of the rope that you're throwing down? There's so many things with safety that do sometimes get overlooked that are really big things. So just make sure you're looking at each component and making sure that you don't have a question. The other thing here with safety that I like to keep things nice and neat. So I didn't use all of this webbing, obviously, but I just stacked it down here out of the way. And this is a lot easier to tell what's going on, that, oh, it's just extra, versus having it all strewn around. Same thing back over here with our 3-wrap-2 pull. This is nice and neat. I have the knot on the front where I can see it and inspect it. Somebody knows what it is and they can recognize it right away. So I think that safety is part of just going around and being sure that everything is just buttoned up and it's picture perfect. So again, we have angle, distance, direction, redundancy, equalization, shock load, and safety. If you can cover all of those and all of those get the green light, that everybody there agrees that all those things are good to go, then you are going to have a safe system. So put your helmet on, get your gloves on, go over the edge, and have a good time. Make sure that you go through that every time that you set up an anchor system. If this is helpful to you and you're interested in learning more about knots, rappelling, climbing, anything like that, then you can check out this playlist up here. And then if you're interested in some other sorts of things that I do, you can check out the video up here. I do a lot of videos about inspiring outdoor adventures and the tips to help make them happen and keep them safe. If you're interested in any of that, I hope that you'll also consider liking and subscribing. And hopefully we'll see you on the next video.